Let's look at how to answer questions on distance-time graphs. First of all, remember that the speed of a distance-time graph is the slope, and slope is rise over run. Also, velocity is distance over time. Distance is the rise, time is the run, and therefore, rise over run is the distance over the time, which is the velocity or the speed. So first, find the speed of each segment. So we will call this segment A, B, C, and D for clarity. Segment A rises by 10 and has a run of 20. So for A, it's a rise of 10, run of 20, do your math, and that's a speed of 0.5 meters per second. 1B, we have 0 slope, so we have 0 speed, 0 meters per second. If you would rather do the math, there's a rise of 0 over a run of, let's see, 20 to 40, that's a change of 20. So a rise of 0 over a run of 20, 0 divided by anything equals 0. For part C, we have a rise. It starts at 10 and goes up to 40. That is a rise of 30. Over a run, it starts at 40 and goes to 60. So that's a run of 20. Rise over run, 30 divided by 20, gives us a speed of 1.5 meters per second. And letter D, we have a rise, actually a fall from 40 all the way down to 0. So that's a rise of negative 40 because it's going back down instead of up. Then there's a run. We start with 60 and we end up with 100. So 60 to 100 is a run of 40. Negative 40 divided by 40 gives us a speed of 1 meter per second. Notice that I'm just taking the absolute value. Number 2, rank the segments from fastest to slowest. How can you tell? Well, there's 2 ways. You could do the math and then rank them from fastest to slowest. Or you could say which one's steepest and which one's shallowest. So letter C is the steepest, so it is the fastest. Letter D is next steepest, so it is second fastest. Letter A is fairly shallow, so it's third. And B has no slope, so it's the slowest. In fact, it's not moving at all. Number 3, which parts are going toward you and which are going away from you? Remember, this is near and this is far. So the ones that are going away from you are going from near to far. So A is going away and C is going away. The one that is going toward you is going from far to near. So D is going toward you. Number 4, what is the person's total distance and total displacement? The total distance is the distance traveled by each segment added together. So in segment A, they went from 0 to 10. So that was a distance of 10. Segment B, they didn't get any further away, so that's a distance of 0. Segment C, they went from 10 to 40, that's a distance of 30. Segment D, they went from 40 all the way back down to 0, that's a distance of 40 for a total distance of 80 meters. And that is the distance. The displacement is where you started to where you finished. You started at 0. You ended at 0. Therefore, the displacement equals 0 because you started exactly where you finished. Notice that we're only looking at the x-axis for distance. We only look at the y-axis for time, and we look at the slope for velocity. Now let's take a look at the second page. What distance has the person traveled at 120 seconds? So we find seconds on the x-axis, 120, and we find the distance on the y-axis, which is just over 400. I'm going to pretend that this line is exactly at 400, this one's exactly at 1,000, etc., to make our life so much easier. So at 120 seconds, the distance is 400 meters. At 240 seconds, the distance, we have traveled 400 plus 600. That's a total distance of 1,000. Then at 300 seconds, we have come back. So we traveled 1,000 meters away, plus we went from 1,000 back to 800. That's 200 meters coming back. So that's a total of 1,200 meters. At 510 seconds, we have gone from 800 meters up to 1,600. So that's an extra 800 meters. So we have the 1,200 we already traveled plus an extra 800 for a total of 2,000 meters. Remember, distance adds together every segment. Now, displacement is a little bit different. The displacement must only take into consideration how far away they are from where they started. So how far away are you from zero? At 120 seconds, we are 400 meters away from zero. At 240, we're 1,000 meters away from zero. So those are still the same, but then it gets different. Here, we are 800 meters away from zero. And here, we are 1,600 meters away from zero. So you see, distance adds up everything. Displacement just says how far are you away from where you started. Now, let's label these segment A, B, C, D, E, and F. During segment A, you are moving away. There is a steady slope, so there's a steady or constant speed. So, on segment A, you are moving away at a constant speed. Segment B, the distance is not changing. Therefore, it's not moving. It's sitting 400 meters away, not moving. On segment C, once again, the object is moving away at a steady velocity or steady speed. Letter D, the object is going from 1,000 meters to 800 meters. Therefore, it's coming closer. It's returning or coming back. It has a steady speed because it's a steady slope. Letter E is flat, therefore this part is staying still again. It is doing this at a distance of 800 meters away from the start. Finally, letter F is a curved line. Therefore, we look at the slope. It starts out with very shallow and very slow, then gets steeper and faster and steeper and faster. So this is speeding up. It is also moving from near to far. Therefore, this is speeding up while moving away. Finally, is the person traveling the fastest during segment A, B, C, D, or E? We're not worried about letter F because the speed is changing. The steepest slope is going to be moving the fastest. So is that A, C, or D? Well, let's look at each one because I'm having trouble telling which slope is the steepest just by looking at it. So I need to do some calculations. This one is having a rise of 400 and a run of halfway between 60 and 120 would be 90. So we have A has a rise of 400, a run of 90, and 400 divided by 90 gives me a slope of 4.4. Section C, we start at 400 and go up to 1,000. That's a rise of 600. Notice that the in-between lines are every 30. So 0, add 30 and you get 60, add 30 and you get 90, you get the idea. In segment C, we started at 150 and we ended at 240. 240 minus 150 gives you 90. 600 divided by 90 gives us a slope of 6.7. For letter D, even though it's a negative slope, we'll just take the absolute value because the negative just means it's coming back. You can't go less than 0 miles per hour or 0 meters per second. So D had a fall from 1,000 to 800. That's a rise or fall of 200. And it was from 240 to 300. Therefore, 300 minus 240 gives you 60. 200 divided by 60 gives you a slope of 3.3. Therefore, the steepest line is actually part C. Now, if you could tell that by looking, more power to you, but I was having trouble seeing it.